All right, so we are going to start with functions. We need to be able to determine what is and is not a function. So first we need to know the definition. For a function, each input results in exactly one output. Okay, and the idea behind that is whatever you put in, you should be able to predict whatever you're going to get out. That, or it should at least be different based on what the input is. So if you work for 5 hours and you get paid $40, and then you work for 5 hours and you get paid $20, does that make sense to you?
No. Yes.
No, that input has two different outputs. I'll be hiring you for some work later. All right. The input is what you put into it. The output is what you get out of it. Whenever we're talking about a function, so let's say if we're paying for an item, that item should cost the same per unit, right? So let's say I'm selling candy bars and you buy 5 candy bars. Let's say they're $2 a piece, that's $10. But if I sell candy bars to Jonathan and he gets 5 candy bars for $5, is that fair? No, it's a different amount. And so that's kind of what a function is. A function has that, you can kind of predict what's going on with it, or at least each input has one output. An input on a graph is the x value. Another word for input is domain. Domain is just a list of all of the values that are the x value. Output or range is all the values on the y values. Output is the y. And so we have ordered pairs where we pair up an input with an output, or an x with a y. Okay. We're going to be looking at things that are functions and comparing them to things that are not functions. Okay. So this one, it is going to be a function. This one, it's not a function. And if you look at the two different, these are called mappings, okay? And we just have the domain, or the x values, the inputs, and the range, which are the y values. So what is the domain? The domain is 1, 2, 3. What is the range? 4, 5, 6, okay? An input of 1 has an output of, so put that in the table. We're going to go ahead and fill out that table, 1 and 5. An input of 2 has an output of 4, and an input of 3 has an output of 6. And so a mapping gives the same exact information as a table does. Okay, the table can be horizontal or it can be vertical. This is the exact same table. We're just stacking it the other direction. So it's still 1, 2, 3 for the x values and 5, 4, 6 for the y values. It's the same exact table, just one is on its side and one is vertical. Okay, this mapping is slightly different. What's different about it?
It has one number has two ranges.
Yeah, 2 outputs. Yeah, 1 has an output of 5 and an output of 6. So in the table, 1 has an output of 5, 1 has an output of 6, 2 has an output of 4, and 3 has an output of 6. What's different about this is that the input has 2 different outputs. We have an output of 5 and an output of 6 for the input of 1. And that's what makes it not a function, because that input is repeated, but the outputs are different. So whenever you're trying to determine whether a table or a mapping is a function or not, look to see if any of the inputs are being used more than once, and that's kind of a giveaway. All right, rewriting these as ordered pairs. So we went from a mapping to a table. So from those 2 pieces of information, let's pair them up, which you kind of already have. 1 is paired with 5, 2 is paired with 4, 3 is paired with 6 for this mapping. I just pulled them directly off of the table. And the other list of ordered pairs is going to be what? Yeah. 1, 5, 1, 6, 2, 4, 3, 6. It's just looking at it as an ordered pair. The same rule applies to look to see whether it is a function or not. Look at the inputs or look at the domain. Okay, and you see that you have a 1 repeated, so the 1 has 2 different outputs paired with it. It's not a function. The x value should never repeat. In other words, the input. The input is the x value. Okay, so now we're going to graph these two sets of information. You can graph the ordered pairs on this one and the ordered pairs for not a function on this one. These are counting by ones. It's the first quadrant. So this goes to 6, and this goes to 6. Okay, the first ordered pair is 1, 5, so go over 1, up 5. Remember, the first value is left and right. The second value is up and down. So over 2, up 4, and then over 3, up 6. And then on the other graph, we have over 1, up 5, over 1, up 6, 2, 4, 3, 6. Okay, and so if you look at this first graph, for each input, there's only 1 point listed. So for an input of 2, there's only 1 value here. For an input of 3, there's only 1 value here. But if you look at this graph, 1 has 2 points listed above it. And that's what makes it not a function, because that space is being used twice. And on the back is kind of talking about what that is that we're doing. The vertical line test. First of all, what direction is vertical? It's not slanted, that's diagonal.
No, that's
Vertical is up and down. Okay?
8th grade, man.
Up and down. You need to know what vertical is. You also need to know what horizontal is. So the vertical line test, you can draw a vertical line anywhere on a graph. If it crosses the graph more than once, it is not a function. Okay, and to be clear, these are 4 quadrants that you're seeing. That's what this heavy plus sign is in the middle. The graph itself is the figure on top of that. So this S curve is the graph. And they said if you can draw a vertical line, does it ever hit it more than once? So if you're drawing, you can use the grid marks as your vertical lines if you want. Does it hit this graph more than once in any place?
No.
This one, it only hits it once. This one, it hits it 1 time. And if you check all of them anywhere, if it ever hits it more than once, then it's not a function. So this one, it doesn't break that rule, does it? So this is a function. Okay, but if you look over at the next figure, the circle, when you draw a vertical line through it, does it hit it more than once?
Yes.
Yeah, and you can show that by putting the little X's here and here. They're on top of each other. And so since it hits it twice in one spot, it's not a function. Okay, this next one, the bottom left. Is there anywhere where if you draw a vertical line through it, it's going to hit it more than 1 time?
No.
And I mean, you can draw them everywhere. It only ever hits it 1 time. So this one is a function. All right, and what about the next one?
Not a function.
Not a function. Almost anywhere on it, it's going to hit it more than once, right? So this is not a function. Let's do one extra. And then I'm going to draw my graph. Is that a function?
No.
Why not?
Because the little tail whipping thing on the bottom.
When I went backwards on this part, it stopped being a function because if you draw a line through that, it hits it in two places at the same time. So that's not a function.
It depends on where you put it.
That's why you have to check the whole thing. So you can kind of eyeball this and tell it's only ever going to hit it once on all of these, but all it has to do is fail it one time, and it's not a function. So there is no room for error. There are no second chances. If it fails it in one spot, it is not a function. So if I were to give you a graph of ordered pairs, such as points, right now this is a function because none of them are on top of each other, right? But as soon as I put one point on top of the other, it's no longer a function because it hits it twice.